All right, let's go. Number 9. The universe is far, far bigger than anything we will ever be able to see. Let me start with a fact that sounds simple, but that has consequences so disturbing that most people never stop to think them through. When you look up at the night sky, you are not seeing the universe. You are seeing a tiny bubble of it, a region that astronomers call the observable universe. And the word observable is doing an enormous amount of quiet, terrifying work in that phrase. Here is what it means. Light travels at a fixed speed. The universe is about 13.8 billion years old, which means that the farthest we can possibly see in any direction is the distance light has been able to travel since the universe began. Because of the expansion of space, that distance works out to about 46 billion light years in every direction. A sphere 93 billion light years across, with us sitting exactly at the center. Not because we are special, but because that is the limit of how far light has had time to reach us. Everything inside that sphere we can, in principle, observe. Everything outside of it we cannot. Not now, not ever. Not with any telescope we could ever build, no matter how advanced, because the light from those regions has not had enough time to reach us, and due to the accelerating expansion of the universe, it never will. Now here is where it becomes disturbing. The observable universe is not the whole universe. It is just the part we can see. And the evidence increasingly suggests that the actual universe, the whole thing, is vastly, almost incomprehensibly larger. How much larger? The most conservative estimates, based on the measured flatness of space, suggest the true universe is at least 250 times larger than the observable portion. That is the floor. That is the smallest it could reasonably be. The realistic estimates are far worse. Some models, based on the theory of cosmic inflation, suggest the true universe could be larger than the observable universe by a factor of 10 to the power of 23, a number so large it has no meaningful comparison in human experience, and some models suggest it may simply be infinite, endless, going on forever in every direction, filled with galaxies we will never see, stars we will never name, and possibly civilizations we will never know existed. We are like a person standing in a small clearing in the middle of the night, holding a candle. We can see a few feet in every direction, and we have convinced ourselves that the few feet we can see is the world. But the darkness beyond the candlelight is not empty. It is where almost everything actually is. And the most unsettling part is this. We are not just failing to see the rest of the universe. We are being actively, permanently cut off from it every second because space itself is expanding faster than light can cross it. More galaxies slip beyond the edge of what we can ever observe. They are not moving away through space. Space itself is growing between us and them, and once they cross that line, they are gone, forever, unreachable, unseeable, as if they never existed at all. Number 8, the galaxies being pulled towards something outside the universe. In 2008, a team of astronomers led by Alexander Kashlinsky was studying the motion of distant galaxy clusters. They were measuring how these enormous structures, each containing thousands of galaxies, move through space. What they found should not have been possible. Hundreds of galaxy clusters were all moving in the same direction. Not randomly, the way you would expect if their motion was caused by the gravity of nearby structures. They were streaming coherently together toward a single specific point in the sky at speeds of up to 1,000 kilometers per second. Kashlinsky called this phenomenon dark flow, and here is why it terrified cosmologists. According to the standard model of the universe, on the largest scales, everything should be smooth and uniform. There should be no preferred direction. Galaxy clusters should move more or less randomly, tugged this way and that by the gravity of their neighbors. But they were not moving randomly. They were all being pulled toward the same place. The problem is what is doing the pulling. Because when astronomers looked in the direction the clusters were streaming toward, they found nothing there big enough to explain it. Nothing inside the observable universe has enough mass to pull hundreds of galaxy clusters in a coordinated flow at those speeds, which led to a conclusion so strange that many cosmologists still refuse to accept it. Whatever is pulling these galaxies may not be inside our observable universe at all. It may be something beyond the edge, something outside the region we can see, some vast concentration of mass, or some structure, or some feature of the larger universe exerting a gravitational pull on our region from beyond the horizon of everything we can observe. Think about what that means. If dark flow is real and the debate is still ongoing, then we are detecting the gravitational influence of something we can never see, something that exists outside the boundary of our observable reality, reaching in, tugging on the galaxies of our universe, leaving a fingerprint we can measure, but a cause we can never identify. It would be the first evidence ever of something beyond the edge of the observable universe, and it would be pulling us toward it. Number 7, the cold spot that might be a bruise from another universe. We have talked about the cosmic microwave background before. It is the leftover radiation from the Big Bang, the oldest light in existence, filling the entire sky with an almost perfectly uniform glow. And for the most part, it is exactly as smooth as the standard model predicts. Except for one place, there is a region of the sky about 1.8 billion light-years across that is significantly colder than it should be. It is called the CMB cold spot, and after more than 20 years of study, it remains one of the most stubborn, unsolved anomalies in all of cosmology. Astronomers have tried every conventional explanation: a giant void, a region with fewer galaxies, cooling the light passing through it. But the voids we can find are not big enough, a statistical fluke, but the statistics do not support it. The cold spot is too cold, too large, and too well-defined to be easily dismissed as random noise, which has left the door open for a far more radical explanation, and it is one that a serious minority of cosmologists have proposed in peer-reviewed journals. The cold spot could be a bruise, a scar, the physical imprint left on our universe by a collision with another universe. The theory works like this: if cosmic inflation is correct, and if our universe is just one bubble in a much larger multiverse of other bubble universes, then early in our universe's history, our bubble may have collided with another bubble, another entire universe brushing against ours at the very beginning of time, and the point of contact would have left a mark, a region of the cosmic microwave background that is subtly different from everything around it, a cold, quiet, anomalous patch, exactly like the one we see. If this interpretation is correct, then the cold spot is not a flaw in our data. It is a wound, direct physical evidence that our universe is not alone, that there are other universes out there, beyond the edge of ours, and that at least one of them, once, long ago, touched us. We would be looking at the fingerprint of another reality, pressed into the oldest light in our own. Number 6, the direction the universe is not supposed to have. There is a principle at the foundation of modern cosmology. It states that the universe has no preferred direction. Look any way you like, and on the largest scales, the universe should look the same. There is no up, no down, no special axis, no orientation. This is one of the bedrock assumptions of the entire field. In the early 2000s, cosmologists mapping the cosmic microwave background in fine detail found something that should not be there. When they analyzed the largest scale temperature patterns in the ancient light, they discovered that these patterns seemed to be aligned along a single axis, a specific direction running through the entire universe. The patterns were not random. They lined up as if the universe, at the largest possible scale, had an orientation, a structure, a direction that the standard model says should absolutely not exist. Cosmologists, with their characteristic dark humor, named this alignment the axis of evil, and in the 20 years since it was discovered, they have been unable to make it go away. It has been confirmed by multiple independent space missions using different instruments with different methods. The alignment is real. The universe, at the largest scale we can measure, appears to have a preferred direction. The implications are deeply uncomfortable. If the universe has an axis, then one of the foundational assumptions of cosmology is wrong. The universe is not the same in every direction. It has a structure we cannot explain. And that structure aligns suspiciously with the plane of our own solar system, which should be a complete coincidence, and which nobody has been able to explain. Some cosmologists think it is a measurement error that we have somehow failed to identify. Others think it is a hint that the universe is shaped in a way we do not understand. Perhaps it is finite and curved and rotating. Perhaps the axis is the imprint of something from before the Big Bang. Perhaps it is the signature of the larger universe beyond our horizon. horizon, imposing its structure on the small part we can see. Nobody knows, but the universe has a direction, and it is not supposed to. Number 5, the invisible mass pulling our entire galaxy. Our galaxy, the Milky Way, is not sitting still. It is moving through space at an astonishing speed, roughly 630 kilometers per second. That is over 2 million kilometers per hour, and for decades, astronomers have been trying to understand what is pulling us. The answer, as far as we can tell, is something called the Great Attractor. The Great Attractor is a region of space, about 250 million light-years away, toward which our galaxy and thousands of others are all being pulled. It is a gravitational anomaly so powerful that it is dragging the entire local group of galaxies, including the Milky Way, toward it at millions of kilometers per hour. And here is the frustrating, unsettling part. We cannot see it. The Great Attractor sits in a region of the sky that astronomers call the zone of avoidance. It is directly behind the dense central bulge of our own galaxy, blocked from view by the thick clouds of stars, gas, and dust at the heart of the Milky Way. Every time we try to look directly at the thing that is pulling us, our own galaxy is in the way, so we know it is there. We can measure its pull, we can calculate roughly how much mass it must contain, and the number is staggering, the equivalent of tens of thousands of galaxies worth of mass concentrated in one region. But we cannot get a clear look at what it actually is, and it gets stranger. In recent years, astronomers have discovered that the Great Attractor itself is not the final destination. It too is being pulled towards something even larger, an immense concentration of mass called the Shapley supercluster, far beyond it. And beyond that, there may be structures larger still. We are falling. Our galaxy, our solar system, our planet, everything is falling through space toward a series of massive, mostly invisible structures in a chain of gravitational attraction that leads outward toward the edge of what we can see and possibly beyond it. We are not drifting peacefully through a static cosmos. We are being pulled at unimaginable speed towards something enormous that we cannot fully see and do not fully understand. Number 4, the two measurements of the universe that cannot both be true. This one is different from the others. It is not about a distant object or a strange signal. It is about a crack in the foundation of physics itself. And it has become, in the last few years, the single biggest crisis in modern cosmology. It is called the Hubble Tension. Here is the problem. There are two completely different ways to measure how fast the universe is expanding. The first method uses the cosmic microwave background, the ancient light from the early universe. By studying the patterns in that light, cosmologists can calculate the expansion rate with extraordinary precision. This method gives one answer. The second method looks at nearby objects, specific types of stars and supernova, whose true brightness we know, allowing us to measure their distances directly. By observing how fast these relatively close objects are moving away from us, cosmologists can calculate the expansion rate a completely different way. This method gives a different answer. The two answers do not match, and they do not match by a lot. The discrepancy is far too large to be explained by measurement error. Both methods have been refined, checked, and rechecked for years by different teams using different instruments. The two numbers stubbornly refuse to agree. This should not be happening. There is only one universe. It has only one expansion rate. If two reliable methods of measuring it give two different answers, then something in our understanding of the universe is fundamentally, deeply wrong. The Hubble tension has grown from a minor curiosity into a full-blown crisis because the implications are enormous. It could mean there is a completely unknown form of energy in the universe that we have not accounted for. It could mean that dark energy, the mysterious force accelerating the expansion of the universe, is changing over time. It could mean that our entire model of cosmic history has a missing ingredient. Or it could mean something even stranger about the region of the universe we happen to live in. Some cosmologists have proposed that we might be sitting inside a giant cosmic void, a region of the universe that is less dense than average, which would distort our local measurements of expansion. If true, it would mean our entire neighborhood of the cosmos is anomalous, that the small part of the universe we can see is not representative of the whole, and that everything we have concluded about the universe, based on our observations from inside inside this bubble may be skewed by the strange region we happen to inhabit. Whatever the answer turns out to be, the Hubble tension is telling us something we do not want to hear. Our picture of the universe is incomplete. There is a missing piece, and until we find it, we do not truly understand the cosmos we live in. Number 3, the theory that universes are being born forever without end. Cosmic inflation is one of the most successful theories in the history of physics. It proposes that in the first fraction of a second after the Big Bang, the universe expanded at an incomprehensible rate, doubling in size over and over, faster than the speed of light, before settling down into the slower expansion we see today. Inflation explains a huge number of features of our universe that would otherwise be mysteries. It is widely accepted. The evidence for it is strong. But inflation has a consequence that many of the physicists who study it find deeply disturbing. Once inflation starts, it may never fully stop. This is called eternal inflation. And the idea works like this. In most models, the rapid inflationary expansion does not end everywhere at the same time. It ends in some regions, creating universes like ours, bubbles of normal space where inflation has stopped and galaxies can form. But in the space between and around these bubbles, inflation continues forever, endlessly generating more space, which then spawns more bubble universes, which are themselves surrounded by regions of ongoing inflation, spawning still more universes without end. If eternal inflation is correct, then our universe is not the universe. It is one bubble, one pocket of calm in an infinite, eternally inflating sea, and beyond the edge of our observable region, past everything we can ever see, there are other bubbles, other universes, an infinite number of them, being created continuously, each one potentially with different physical laws, different constants, different histories. Some of them might be nearly identical to ours. Some might have slightly different physics. Some might be so alien that nothing we understand about reality would apply there at all. And there would be infinitely many of them, forever beyond our reach, separated from us by regions of space that are expanding faster than light, guaranteeing we can never, ever visit or observe them. We would be one bubble in an infinite foam, drifting in a sea of universes we can never know. Number 2, the possibility that the universe is flat and therefore infinite. One of the most important things cosmologists have tried to measure is the shape of the universe. Not the shape of galaxies or clusters, but the overall geometry of space itself. And the answer to that question determines the ultimate fate and size of everything. There are 3 possibilities. The universe could be closed, curving back on itself like the surface of a sphere, in which case it would be finite. If you traveled far enough in one direction, you would eventually return to where you started. The universe could be open, curving away from itself like a saddle, or the universe could be flat, with the geometry of ordinary space extending in straight lines forever. For decades, cosmologists have measured the geometry of the universe with increasing precision, and the answer that keeps coming back is that the universe appears to be flat, almost perfectly, precisely flat, to within a tiny margin of error. And a flat universe has a staggering implication. If the universe is truly flat and not curved in some way too subtle for us to detect, then it is almost certainly infinite, endless, extending forever in every direction, containing an infinite number of galaxies, an infinite number of stars, and following the logic to its conclusion, an infinite number of everything. Because here is what infinity does to probability. In an infinite universe, anything that has a non-zero probability of happening, no matter how small, will happen. Not just once, but an infinite number of times, which means that somewhere out there, beyond the edge of what we can see in the infinite reaches of a flat universe, there are other Earths, an infinite number of them, other versions of our solar system, other versions of our planet. And following the mathematics to its unavoidable conclusion, other versions of you, an infinite number of copies of you, scattered across an infinite universe, some identical to you in every way, some different in small ways, some different in enormous ways. Right now, reading these words or living entirely different lives in regions of the universe so far away that the light between you will never, ever meet. This is not mysticism. It is the direct logical consequence of a flat, infinite universe. And every measurement we have made says the universe is flat. Number 1, we are trapped inside a shrinking bubble, and the walls are closing in. Everything we have discussed so far leads to a single, final, deeply unsettling conclusion, and it is one that most people never fully absorb because the human mind resists it. We are trapped. The observable universe, the bubble of everything we can see, is not stable. It is shrinking. Not in the sense that space is getting smaller, space is expanding, but the amount of the universe we can observe, the fraction of reality that is accessible to us, is decreasing continuously right now. Here is why. The expansion of the universe is accelerating. It is being driven by dark energy, a mysterious force that is pushing everything apart faster and faster. And as the expansion accelerates, distant galaxies are being carried away from us at ever-increasing speeds. Eventually, those galaxies cross a threshold. They begin receding faster than the speed of light, not because they are moving through space that fast, but because the space between us and them is expanding that fast. And once a galaxy crosses that threshold, its light can no longer reach us, ever. It slips beyond the edge of the observable universe and vanishes from our reality permanently. It does not explode. It does not die. It simply fades, redshifts into invisibility, and is gone, cut off from us forever by the expansion of space itself. This is happening right now. As you watch this, galaxies are crossing that line and disappearing from the observable universe one by one, never to be seen again. And it is speeding up. In the far future, this process will accelerate to a horrifying conclusion. Trillions of years from now, the accelerating expansion will have carried every galaxy outside our own local group beyond the horizon. The night sky will be empty. Any astronomers alive then, if there are any, will look out into the cosmos and see nothing but their own galaxy, floating alone in an apparently empty, black, infinite void. All evidence of the wider universe, all the other galaxies, all the history of cosmic expansion, all of it will have vanished beyond the edge of visibility. They will have no way of knowing the rest of the universe was ever there at all. We are living in a privileged moment, a brief window in cosmic history where we can still see other galaxies, still detect the cosmic microwave background, still piece together the story of where we came from. That window is closing. The bubble of the observable universe is, in the deepest sense, a prison, and its walls are moving inward, sealing us into an ever smaller island of visible reality, surrounded by an infinite darkness we can never cross, containing an infinite universe we can never reach. We are not the center of the cosmos. We are not the masters of space. We are prisoners inside a shrinking bubble of light, floating in an endless darkness that is quietly, permanently closing us off from almost everything that exists. And that senior astronomer some of you have asked me about, the one who allegedly said off the record that he wished we had never looked. When he said it, he was not talking about a single discovery. He was talking about all of it, about what happens when you finally understand the true size of the universe and the true smallness of the part we can reach, and the fact that the door between us and everything else is slowly, silently swinging shut. Once you understand the observable universe for what it really is, you cannot unsee it. And you begin to understand why some of the people who understand it best sometimes wish they did not. If this video expanded your sense of the cosmos in a way that unsettled you, then you should know there are older discoveries, older mysteries that point toward the same conclusion and that most people have never heard of. I made a video about those. It is on the screen right now. If this one kept you up, that one will keep you up longer. And if you want to be here the moment the next discovery drops, hit subscribe, because our picture of the universe is changing faster now than at any point in history. And the next thing we find beyond the edge may be the strangest yet. All right, see you in the next one.